Hello folks, we are taking the part 9 and the last part of this exercise 3.3. It's a lengthy exercise with so many problems. So this is going to be our last part and I have put up the problems on the board. We'll see how we can prove all this and get the result. So we probably have to do, I suppose, 25 problems. Yes, we have, it was a huge exercise with 25 problems and all huge concepts also. And concepts, you can't say huge if you have those formulae, as we have had our tables into our system, multiplication tables into our system. If you have these formulae into your system, then working is just, it goes on quite quickly. But you should have the stock of formula with you. You have to, for that you have to meticulously memorize it. There's no other way, there's no alternative. Though there are some little bit of aids to memorize it, but then it's better you get it into your system by some means. So let's continue doing this. We are taking up the 23rd problem, which says that tan 4x is all that. To start with, let's get ourselves familiarized with the tan 2x formula. We know that the tan 2x is 2 tan x by 1 minus tan squared x. Basically, we are going to use this to solve this. So for that, first we consider the LHS. And LHS is tan 4x, which is 2 into 2x. We know it is 2 into 2x. Now, 2 into anything, you can apply this formula, right? So it will come to 2 tan 2x by 1 minus tan squared 2x. You have applied the formula. 2 into anything, you can apply the formula. You have applied the formula. Now, because it is glaringly tan 2x, again you can apply the formula. So what will happen? This will be 2 into 2 tan x by 1 minus tan squared x. We have applied instead of this. And then here in the denominator again 1 minus 2 tan x by 1 minus tan squared x, but not so hassle free with a square. So it is coming with a square, and then we need to solve this. So what will come? 2 into 2, it's 4 tan x. This stays as 1 minus tan squared x. But the denominator you need to solve. Here it will come to 1 minus 4 tan squared x when we expand. And this is 1 minus tan squared x whole square. And here therefore we need to simplify, because this is 1, you have to multiply by 1 minus tan squared x whole squared, 1 minus tan squared x whole squared. So many things. So let's see, numerator is perfectly okay, but the denominator you have to do some bit of work. 1 minus tan squared x. The denominator, we have 1 minus tan squared x whole squared, which we are expanding. A minus b the whole squared is a squared minus 2ab plus b squared. So it's coming as 1 plus tan raised to 4x minus 2 tan squared x. We have expanded this. Minus 4 tan squared x whole by 1 minus tan squared x the whole squared. And that's a expansion of, in numerator you have expanded, denominator you have kept it as it is. So how do we solve this? Continue from there over there. So you have it like 4 tan x by 1 minus tan squared x. And in the denominator, let's see the solving. 1 plus tan raised to 4x minus 2 tan squared x minus 4 tan squared x, they are like terms. So they can simplify and it will become minus 6. So 1 plus tan raised to 4x minus 6 tan squared x by 1 minus tan squared x the whole square. So this expression divided by this. That means multiplication by the reciprocal. So what happens is, when you multiply by the reciprocal, logically 1 minus tan squared x the whole squared comes in the numerator and this term comes in the denominator. What is the advantage? You can have this and this cut. One power will get cut, only one power will survive. So what happens on solving? You will get 4 tan x, because one power has got cut there, only one power is left, and you have 4 tan x by 1 minus tan squared x in the numerator. And denominator obviously comes over here. This has already got cut, so only this is left. So you get 1 minus 6 tan squared x plus tan raised to 4x as the surviving term. That is your RHS, and that's how you prove your result. You have proved the result. Okay. Then let us take the problem number 24. The problem number 24 also we do that. Here we use the cos 2x formula. There also we use the cos 4x formula, where we are going to carefully observe the formula. Now cos tan 2x is plain and easy because there is only one formula, but cos has got a host of formulae. So you have to choose the correct formula to get the answer. Because we see this 1 minus, we will take the formula pertaining to that. Cos 2x, there is a formula which says that it is 1 minus 2 sine squared x. That formula we are going to use to get this. Writing cos 4x like before is like writing cos 2 times 2x. So cos 2 into something, you can apply this formula. It is 1 minus 2 sine squared 2x. Just check. Yeah, sine squared 2x. Sin 2x is a very simple formula. 2 sin x cos x. Very simple. We get the work done very fast. So it is 1 minus 2 sin 2x is 2 sin x cos x. The whole squared. Why? Because sin 2x is always written as 2 sin x cos x. We have used the formula. Now let's expand. This will come to 4 sin squared x cos squared x. So 4 2s are 8. 8 sin squared x cos squared x. Only so much. That's how you get it as the RHS, and that's how you prove the result. Right. We started, the thing is you should pick the correct formula from the, always have an eye on the RHS and pick the correct formula. Cos 2x that way is complicated because it has got 3 or 4 formulae. So you have to pick the correct formula and get your work done. Once you pick the correct formula, work is less. Right. Now we go to our last but not the least problem, which is called as cos 6x equal to something. Again, there also we have to make a correct choice of what you are going to take up. LHS, which is cos 6x. There is no harm if I call it as 2 into 3x. Right. Now what formula to choose here? You have a minus 1 appearing there. So we will probably choose that formula which has got a minus 1. Okay. If we do have a choice, why not choose it like that? Cos 2x, there is a formula like 2 cos squared x minus 1. So why not choose that formula? That will be more useful to you. So by that logic here, it is 2 cos squared 3x here, because it is 2 into whatever is coming that you should put here, minus 1. Now cos 3x, we will apply the cos 3x formula and see what comes up. The cos 3x formula is 4 cos cube x minus 3 cos x minus 1 whole square. Just check. Cos 3x formula is 4 cos cube x minus 3 cos x, but because there is a whole square, we put the whole squared also. Right. Now whole squared, a minus b the whole squared, we saw over here it's a squared minus 2ab plus b squared. Let's apply it. So what will come? This will come as 2 times a squared. So that is 16 cos raised to 6x plus 9 cos squared x, then 12, 24 product term, 24 cos raised to 4x minus 1. When we open up, 32 cos raised to 6x plus 18 cos squared x minus 48 cos raised to 4x minus 1. That is exactly what we want there. We've got all the terms. So that's how this becomes the RHS, and that's how we prove the result. So by this we finish our exercise 3.3. It has been a huge exercise. Finish all the problems from there. In the next video we will take the exercise 3.4. Thank you.